Good afternoon, Dr. Francis.
Hello.
Yeah, good afternoon, Doc.
Hey, good afternoon. How are you doing today? Hey, I'm not seeing you since.
Yeah, I said let me come today. Yeah,
How's work going?
we thank God we're managing, we're surviving.
I'm sure you have not had time to be practicing all we have planned before now.
No,
Hey,
I
but
have
you know what we discussed that last time, right? So
yes,
how you
yes,
can learn and work, right? So just think about a use
yeah,
case.
okay,
You know, whatever we are doing, just think about a use case, whether it is for maybe like linear programming. How can I use
yeah,
linear programming to apply either for new
yes,
trends to combine the best and now see how it works? Do you get?
okay,
Or
yes.
that's linear programming.
I
Which other
think
one?
linear programming, the things that I think I
Forecasting.
really need to
Yeah,
work, that really apply to me, linear programming,
yeah.
then that's scenario manager.
Okay, scenario manager. Okay.
Yes, I think I really
Yeah.
love
Maybe
that one.
demand forecasting.
I missed that one. Eh,
No, but we did that one in
um,
school, basically. Demand forecasting.
demand
Demand
forecasting. Did we do it?
forecasting. Yes, now we
Mhm.
did demand forecasting.
Okay, is it like wait, tell it another name. I think it has another name.
It's forecasting and prediction. How we call it? Forecasting and
Yes, yeah. Now you're okay. Yes, we did it. Yes, I know that one. Yeah.
yeah, demand and
Uh,
forecasting. Yeah.
mm.
Yeah, which other one again? Then for database, maybe you can be thinking of how to build a database.
Okay. Yeah,
You
for
get
my
think about to
yeah.
build a database. Then
Okay.
most likely, once you have built that database, then later we'll talk about reporting. That's building
Reporting.
dashboards. Building dashboards.
Okay.
Do you understand?
Oh, yes,
So I think
yes.
what we can do,
Good
let
Yeah.
afternoon,
us,
sir.
yeah, afternoon, Lukman, how are you?
Yes, I'm fine, sir.
Look more welcome. We're doing my own
Vivian,
personal session. Wait first.
no, we won't accept that. Thank you
So
so
what
much,
we can,
Dr. Francis.
yeah, no problem. So
Thank you, sir.
Vivian,
Okay, Dr. Francis.
what we can do,
Yes.
we'll think about how we
Mm.
can use your own as a case study, right? We'll write a case. So
Okay.
subsequently, you can be using your own company for a case study.
Okay.
Yeah, I think that what we can
Okay.
do. So maybe we can just maybe
Okay.
talk anytime you are free, then we'll just discuss. Then
Okay,
maybe
what's
just
the
try and
kind
use
of
your
data I should try to
like,
gather
yeah,
that we
you
can
don't
use
have
to
to use
build the
your real
data?
data. You don't use your real data. What you do, the pattern will be the
Mm.
same, but we can just multiply them by 2, by 3, by for any random number, but the pattern will remain the same.
Okay.
Yeah,
Okay,
that's it.
that's fine. Yeah.
So
Okay.
subsequently, any other person that want to use it here, we can also use it here, and you can also even facilitate the session too, and tell us how it
Okay, that's
actually
fine.
works.
Okay.
All
Okay.
right, that's fine.
Thank you, Doc. Yeah.
All right, no problem.
Yeah.
IJ, how are you? Maria.
Good
Lukman.
afternoon.
Good afternoon,
Yeah,
sir. Good afternoon, sir.
afternoon.
Good afternoon, IJ.
Good afternoon, everybody.
Afternoon.
Good afternoon, everyone. IG, welcome.
Thank you.
Welcome,
Sorry,
Maria.
I missed last session. Very painful, but I'm here.
We missed you, IJ.
As in, my dear,
IJ
I'm
that's
back.
supposed to be injuring us to come. IJ disappeared.
And he sent me a message to send apologies to the house, and I missed the session too. I'm sorry.
You see, even the person I said to help me, even the person did not. Voila.
I'm sorry. Yeah.
It's like we're becoming overwhelmed.
His work hustling, the period is somehow, but we thank God. Yeah.
As well, we'll be fine.
Yeah.
Okay. Anyway, I think by this month we should be done with Python. So we should be done with Python. So basically, what we have done so far, at least we can, if we have followed what we have done, at least we can work as data analyst with Python. Almost every other thing you do in Excel now, we have done it in Python. So the next part we are going into is now machine learning. So maybe if we look at one or two algorithms, I will just show you different algorithms. Then after that, I think the last part will be for deployment, but that one now depends on you guys. So, but after machine learning, I think we can stop there. Then we can enter another thing. Then for those who want to now build on it, then you can build on it.
Okay.
Okay, let me just try. Okay. Is another person still joining?
So I think we can start and they will join us along the way.
Okay, they'll join us along the way. Okay, that's fine. So when did we? So we finished the data visualization, right? I think we did. We are done with data visualization, is it?
Yes, sir.
Using Matplotlib, Seaborn. Then I tried to use Plotly, right? Although maybe when we come back again much later, right? If I were at least done with other programs, other softwares, then we can come back again. Then I will show you how to build dashboards with Python. How to build the dashboards. Okay.
Okay, sir.
So, but today I think what we'll just do, let's get into machine learning because that is another aspect. But you see, machine learning now, the assumption about this machine learning now is that you must have practiced your Python.
Hey.
You must have practiced because now we are going into space. But we have left space now, we are going to another planet. Okay, but what's more important is that it's not just, it's understanding why we are doing it, right? Because most time, if you have seen so far, we try to not to, because sometimes you hear data scientists, data analysts, data engineers. So somehow you start seeing those rules. There are some organizations that one person will do everything, you still call that person data analyst. Some place they will still call the person what a data scientist, data engineer, or business analyst. Okay, but somehow you see some demarcation of their rules. Okay, for example, like the data analyst. So that part we have to do with extracting data, right? Analyzing data, visualizing the data. That's basically where the data analyst job stops. Okay. Now you see the part of where that comes to. So what we have done there is the descriptive analytics and diagnostic analytics. But the part of now predictive analytics to prescriptive analytics, that's where a data scientist now comes in. Okay. So you want to start with predicting. Why has it happened or what will likely happen? Okay. So that's where data scientist, that's where data scientist role now starts from. Although data scientists can do everything end to end, right? But most time when you see most organizations, when they talk about data scientists, is you should have the ability to write machine learning models. Okay, so that's what basically we are going to be doing. So we're looking at machine learning. Okay, and because most of these things again we have done them in class, right? When we are dealing with Excel. Okay, but because it was not programming, but it's actually what we still do. So we'll still go back to revise what we do in Excel, right? So you understand what is happening at the back end. So when we are writing the codes, you'll be thinking about it from an Excel point. Okay, this is what we have done in Excel. So this is what's likely going to be doing. Because if we are just writing the code, you may not have an idea of what is going on at the back end. Okay, so with Excel, you can easily see what's happening. All right. So we'll start with machine learning, isn't it? So I'm sure this word machine learning, we have been hearing it, machine learning, AI, isn't it?
Yes.
So we hear of AI, you go to Jumia, you buy something, they say those who bought this are likely to also buy this. Or you watch Netflix, isn't it?
Yes.
Since you watch this program, you are more likely to, like, it's not recommend for you what you like. What you do is prescribing. It's prescribing. Okay? But it's on the go. It's on the go. As you add a new data now, it will run it again. It will run it again and say, oh, since you like this, you like this. So people who have liked this and like this are more likely to watch this. That's why sometimes you can buy a shirt. We tell you those who bought shirt also bought trousers, or bought wristwatch, or bought a tie. Okay? So that's not artificial intelligence. But you see, before you get to artificial intelligence, machine learning comes before AI. Okay? So that's machine learning. It's just looking at your data to understand the past behavior. You see, that's why when we talk about, when you say progression means what? Progression means what?
Like moving forward. Or...
Moving forward. Wait, what about regression? Regression now means what?
Moving backward.
Moving backwards, going backward in the data to see the past behavior. So once we understand the past behavior, then we can understand the behavior going forward. Okay, so it's when we are now trying to understand going for estimating the future. Okay, and that's why we talked about understanding your time series, the kind of data you're working, whether it's a time series data or cross-sectional data. Okay, and we said that for time series data is data over a period of time, isn't it? Whenever we are estimating data going forward in time, it is known as what? Forecasting. Okay, but cross-sectional data is data at a point in time. Across, can be across industry, across observations at a point in time. So anytime you are estimating an observation, right, within that observation is usually referred to as what? Prediction. Okay. But in practice, you hear them use them interchangeably, but most times you call it prediction. Okay. So what we normally do is based on that model you have designed, right? Based on the algorithm, right? You don't have to now program it so that everything is now done automatically. So as a new data just comes in, it's supposed to just automatically compute everything based on the new information, and now what do is what? Prediction. But you see, the challenge you are going to have is to determine how accurate is that word prediction. That's the major challenge. How accurate is that word prediction? So that's why we need to do some tests to see whether it is what accurate or what or not. Okay, but most times, I'm not saying you are going to be perfect, but most likely it's going to be what? As accurate as what possible. And that's why you see something like your Google Maps. You see, your Google Map is what? An AI, right? It's artificial intelligence, isn't it? Is that not it? And there are some places that you will go to. Even you will know the road more than Google Map. Is that not possible?
Yes.
Is it not?
Yes,
Because
it
there are
is,
some
yes.
parts you can go, Google Map will not see it. But the moment you have passed that route, right? Next time, if you have been passing that route 1, 2, 3 times, going back again, Google Map will now want to know that route again. What is it doing? It's learning from your data. And it's automatic. So that's why we say when we are dealing with machine learning, it's the branch of AI which helps making machines, that is computer, capable of learning from observational data without being explicitly programmed. So I don't have to always go back to program it. No, it's automatic. Okay. So we human beings learn from experience, right? But computer learns from where his own experience is true or the data we give it. Okay. And that's why we see that when we talk about AI, right, there's a whole lot of things that come into it. So you see, machine learning is just one part. There's robotics, there's neural network, there's perception, but this one is where you're still part of your neural networks. Cognitive systems, still part, building knowledge, right? NLP, natural language processing. Okay, because you see, the way we have, like your Google Maps, right? Most times it's in English language, isn't it? Have you heard have you seen like a Yoruba version of it? Or you hear a Chinese version of it? So what they are doing there is NLP, natural language word processing. So the way you are speaking to it, you understand what they are doing. Okay, so there are different aspects of it. So what we are dealing with is what? The machine words learning. Okay, machine learning. It's quite wide, but that's what we are going to be doing. Mostly what? Machine words learning. Okay. So if we remember what we normally do, there's a problem. Is it not? Based on the problem, we just write a program or understand the rules, right? Once you understand the rules, it's the rules. And now we say your domain knowledge is what will determine how you define the rules. So it's based on your domain knowledge. Okay. Then you code it and what? Come up with what? A solution. Okay. So it always starts from what? A problem. Now you see, most times, this thing, when we model the data or write our programs, right, there are sometimes we bound to be errors. Okay, because even when you see things like a Tesla, you can try Tesla, drive it around in the US, all over there, where they may not have potholes. You bring it to Lagos, you are passing through Mushin, the car will not move because he has never recognized a pothole. But as he enters the pothole, it has now landed. Anytime I see a pothole, I will need to what? Slow down, isn't it? So what is happening? It's going to learn from what? On the go. Okay? So sometimes they refer to that as reinforcement learning. So under your machine learning, we have what they call supervised learning, unsupervised learning, and reinforcement learning. So that reinforcement learning is what they refer to as deep learning. It's called deep learning. Deep learning. You see, all these parts is what data scientists are into. Okay, and it's heavily driven by what? Mathematics and statistics. So it's at all these points now you now need to really understand the math, because there's a whole lot, because that algorithm you are seeing is a mathematical procedure. Okay, so that's what you are trying to program. That's why we see that when we look at the data scientists, you must understand statistics and what? Mathematics. Okay. And again, we also need to also understand it's not everything that you need to automate or everything requires machine learning. Okay, some you can just program, some may not need what? Automation. Okay, all this facial recognition, like for example, there are some places you will go, they will tell you to put face mask on. Is it not? If you don't put face mask on, the gate will not open. Okay, that is facial recognition. Okay, because when we talk about data, we are moving beyond just the data you have in your database, the structured data in Excel. It can be pictures, it can be voice, it can be behavior, it can be movements. Okay, all those are also part of what? Machine learning applications. Okay, so for example, a typical example, can you see email? So your email, you can have a spam or not spam. Okay, so that model is what will help you to now classify them into what? Spam or not what? Spam. Okay, so you have to specifically tell it, this is spam, this is not spam, this is spam, this is not spam. That is what they refer to as what? A supervised learning. Supervised. Okay, that's what they call what? Supervised what? Learning. But unsupervised learning, it means that it can just take them and group them into clusters oh, this one have similar characteristics, you don't have similar characteristics, you don't have similar characteristics, and group them. That is unsupervised learning. Okay, but a more advanced part of unsupervised learning is your deep learning. Those ones that now have facial recognition. Can you see that? Do you know all these things you are seeing? Do you know they are all numbers? Everything you are seeing here, do you know there is all data? Because people's face have different structure, isn't it? And there's number attached to it. So it is number is actually seen. Detection, maybe cancer detection, is looking at it based on what picture. So it's just beyond your normal one. But this is the more advanced part. Okay, that's the deep learning. But what we are going to be doing is our normal supervised learning. We'll do some supervised learning and maybe unsupervised learning, okay, if we have time. But mostly we'll do. But however, in practice, you see them doing mostly what? Supervised learning, okay? Unless you don't need to go very advanced before you can also look for some use case, okay? But most time we use what? Supervised learning. So in that supervised learning, what you are simply doing, you are just telling it, you classify the rules, right? This is good, this is bad, this is good, this is bad. This is boy, this is girl, this is boy, this is girl. Okay, you give the features and say this is boy. You give the features, say this is girl. Okay, or you give certain characteristics, say this is good. You give certain characteristics, this is bad. And that is why I keep telling you that even our police, is it not? They also do their own native machine learning. Okay, by the time you see they see a young man driving Mercedes Benz, he has earring, he has tattoo, he's keeping dread, automatically based on the people they have arrested in the past, they will classify him as what?
A criminal.
A criminal. So it can be Yahoo, not Yahoo. Yahoo, not Yahoo. So that's a classification. Okay, but when we are trying to make prediction or forecast about a number, like what's the price of a car, what is the price of the house, what is the stock price, we are predicting or forecasting future stock price. That is what? Regression. So they will tell you there are two types. You have the classification problem and regression what? Problem. Okay, so in practice this is how they do it, but in theory, because everything we are learning here is still statistics. You see, it's still statistics, right? So all the statistics we have been learning is just a branch of mathematics. Okay, but you now see over time now they start evolving them with the different names. In regression, in theory, they will not tell you whether it's a classification problem or not classification problem. Okay, they'll just tell you regression, because regression, remember, is the problem of correlation, isn't it? Problems of correlation that we cannot use it to forecast, isn't it? We cannot separate between dependent and independent variables. We're only interested in direction. But when we are not interested in doing forecast or prediction, we can't use correlation. So we now have to now adopt what? Regression. So you now see that regression is now the tool that we now use to what? Find the relationship, find the cause and effect, and what also do use what? Prediction. Okay, so that's why the foundation is still what? Regression. So irrespective of the algorithm that you see, it has a basis in what? Regression. And they have so many regression algorithms, so many. Okay, but in practice, the way we now do it is that they will now tell us that if you are going to predict a number, like price of a house, price of a car, you get a stock price, right? Exchange rate price, inflation rate, all those are now what they refer to as a regression problem. But where you are going to now classify it as good, bad, bull, bear, as long as a classification issue, boy, girl, you get, as long as a classification issue, they call it what? A classification problem. Like Yahoo boy, not Yahoo boy. Okay, so it is based on those features, they now classify it as this or this. So that's a classification problem. Do we get this?
Yes, sir.
Are we clear with this?
Yes, sir.
Yes,
Now,
sir.
because when you want to see some, when you look at some competitions, like when you go to cargo, by the time you see the data sets, you should be able to tell, is this a classification problem or is this a regression problem? Okay, good. Now you see, for the unsupervised learning, you are not the one that will tell it whether it's good or bad. It will classify it based on what characteristics. Okay, and that characteristics is what is now referred to as what clusters. You put them in what cluster. That means this one they have similar what characteristics, similar characteristics, similar characteristics, similar characteristics. That's why you can see one around here. It will not tell you the chance that it can classify it either here or here. Can you see that? So there are some that the features are so close, but it now has to do some word prediction. They do not tell you whether it is this or this. So that's why the target variable is unknown. You know what the target variable is? You know, in regression, where we have y as a function of what? X, is it not?
X, yeah.
In theory, we say y is what? What is y? Y is what?
Income.
Dependent
Dependent variable.
variable.
X is what?
Independent.
Independent variable.
In practice, what you will hear, you will not hear dependent variable. They will call this one target. They say this is the target variable. Okay, the target. Why this is called what? The features. It's called what? The features. Okay. So anytime you hear, oh, feature selection means what? When you hear feature selection, what does it mean? Feature selection. Feature selection. What does it mean? When you say feature selection. In English language, what does selection mean?
Picking something.
Picking. What is feature?
An independent variable.
So feature selection simply means what?
Selecting your independent variable.
That's all. You are just picking what your independent variable. That's feature selection. When you hear feature engineering, what does that mean? Feature engineering.
Creating your independent.
Exactly. You are creating a variable from already existing variable. It's called feature engineering. Can you see that? Okay. So these are called features, and this is so for your supervised learning. So we say under machine learning is made up of two parts: supervised learning and what? Unsupervised learning. What's the difference? That in supervised learning, we know the target. Is it not? We know the target variable, and it has labels. And it has what? Labels. Is it not? But for unsupervised learning, the target is unknown. Unknown targets. Unknown targets. So that's the basic difference. That for supervised learning, we know the target. Based on this feature, we classify it as this or classify it as this. But under this one, we don't classify it as anything. We just group them. So that's why we call clustering. So there's an algorithm known as what? Clustering and dimension reduction. Okay. Are we clear with this?
Yes.
Clear? Okay. But the most important thing I just need to learn is that supervised learning for now, because that will be our major focus. But you see reinforcement learning. That reinforcement learning, just like we have machine learning, that under your unsupervised learning is your what? Deep learning. Is deep what? Learning, which is also referred to as what? Reinforcement learning. So when we talk about AI, so this is where AI now falls in. Because without this, you cannot do it automatically. But this one now, the difference now is that you are not the one that will even give it feature. It's the one that will generate data, learn from the data, do his own classification, do his own recommendation, to do everything. So that is why you see something like Tesla, that Tesla car, right? What it's doing there is what? Reinforcement learning. So it's looking at picture around. Okay, I've seen a human being. So anytime I see a human being, I'm expected to stop. Anytime I see a pothole, I'm expected to slow down. Anytime I see another car, I'm expected to stop. But you see, that is why there's a point AI can go that irrespective of it, we are trying to what? delegate decision making that you're supposed to have made to what? A machine. Isn't it? Because if you see a hole, right, a big hole, by what it has been programmed to do, what is the car going to do once it's a ditch here? What is it expected to do?
Slow down.
Change
Stop.
the lane.
Either slow down or stop completely, or stop, isn't it? Or if he cannot stop, what can he do? He can divert, right? Now, if he's a human being, right? You see, and that's one thing you cannot program. Can you program emotions?
No.
No.
No,
Can you program emotions?
No.
no,
Empathy. Can you program empathy?
No.
And sometimes these are the things that also drive decisions. Is that not true?
True.
So, in as much as yes, we want to make our life easy, by automating it, there are still some things that we still need human approval for to see whether this makes sense or not. Okay, so it's just like saying, oh, this is a ditch, right? And there's a child, and this is a child. Do you see that? As a human being, what will you have done? As a human being, what will you have done?
Slow out the.
Either slow down or stop completely, is it not?
Yes.
Yes.
But for a machine, it's already pre-programmed. If I cannot stop, you have to divert. It's already pre-programmed already. And that's why we need to also take into consideration the ethics.
That's true.
Do you get? There are some things we need to be careful about. Okay? Yes, we want to outsource decision making, but it's not everything we can actually outsource. Okay? So these are now the challenges you may now have with such issues. Okay? But yes, it actually makes life easy for you. Okay? But there are still some parts that we cannot completely give it to machines. That's complete power. Okay? Because right now, you see them now, there are some hotels now, you don't even see human beings now, it's only machine, like in Japan. You see only machine all through. Even now, they are even doing such a way, even secretary is now an AI. It's now a doll baby that can do everything a secretary can do. Receptionist. So now you are now seeing that with AI, they are gradually replacing jobs that are repetitive. Okay. The implication is that, what's the implication of that? As AI keeps growing and they keep implementing the organization, what do you think is the problem?
Redundancy of humans.
Redundancy, isn't it? Redundancy, which means there's likely to be increased unemployment.
Yes.
That means that the job 5 people are expected to do, you just need only 1 person now. Is it not? And that person just to supervise. But for them to keep that 1 person, the person who can understand how to automate and understand that automation process. So if anything goes down, he knows how to fix it. Do you get? That is why you see almost every role, every field, you don't see that gradually people are now learning to be more analytical, learning programming, learning different kind of things now, because now the skill needs to be improved significantly. Because if they were to drop out people, it is only those who are still relevant, whose skills are still relevant in the workplace. So that's why you see so many people are going into programming right now. Okay, but the point here is that yes, we need to learn all these things, but we also know there's a limitation. Okay, there's a limitation based on that. Okay, so I've explained all this. Yes, supervised, unsupervised. So I'm sure we are clear with these concepts now, isn't it?
Yes, we are.
You can see,
Yes,
you can see how they are describing it, right? Under here.
Yes.
You supervise learning,
Yes.
label data, direct feedback, predict the outcome of feature. But here, there's no labels, no feedback, is it not? Everything is just going to do it on its own automatically. It is reinforcement that is the highest level of it. Okay. So sometimes you see them group into 2, sometimes they group into 3. Okay. But if you are learning, you just understand basically there are two types, basically, right? But much later, this reinforcement can be under unsupervised. So learn from mistakes. It's just like a child, is it not? A child. So a child can be like this reinforcement. The child's brain, for example, you just leave the child to do everything on his own. The child will pick sweets, put them in his mouth. Oh, this is nice. The child will pick lime, put in his mouth. You see, you do not tell the child anything, though. But because the child always like putting things in his mouth, is it not? Child will see sockets. He has never seen socket in his life. So see, socket is just a white thing, is it not? So let me go and try and put my hands. By the time he shocks the child, by next time I start crying, will he go there again? So over time, his brain is learning from mistakes. His brain is learning. He's learning. Or anytime I see line, anytime I see anything on the wall, now, no, I will not do that. But supervised learning is that you will tell the child, this is good, this is bad. This is good, this is bad. Can you see that? So that is the word supervised learning. They are labels, good, bad. But the reinforcement learning is the advanced level of unsupervised learning. So the child will be learning on his own to now say, okay, this is good, this is bad. Okay? So those are the basic things. Now you see, you have so many algorithms you can use, so many algorithms, okay? So there's a theory called no free lunch theory. No free lunch. Have you heard of this one? No free lunch. And what it's simply saying is that, okay, there are so many algorithms. So how do I know which one is the best? Can you see that? It's telling you that there is no one best algorithm. So that is why you see people try different algorithms. The objective is to what? Predict to be as accurate as what possible. Okay? So that no free lunch theory is simply saying that what? There is no one algorithm that works for every what problem. So it is your understanding of the problem. And remember, the problem can either be what? A regression problem or what? A classification problem. Each of them have their own algorithms. Okay? The algorithm I will choose depends on what the data sets. Because the problem is what we define which data set I'm going to use. So that's why whenever you see a data set, by looking at it, you should be able to tell, is this a regression problem or is this a word classification word problem? So how will you know if it's a regression problem or classification problem? How will you know?
Regression has targets outputs, like
Yes.
talking towards something. But classification is based on description, I think.
It's based on what?
Description.
Description. Okay. Based on
Maybe that's not the right word.
Characteristics.
okay.
Attributes.
I think.
Features.
Features. Okay. Now, for example, if you have stock price, is that a regression problem or classification problem?
Regression.
It will be regression problem.
Regression. Fraud or not fraud?
That's classification.
Classification. So how do I know? I will look at the target variable. Once I look at the target variable, what is the target variable?
That's the dependent variable.
Dependent variable, exactly. That's dependent variable. Once if I see that dependent variable has numbers, random numbers, it can be 5, it can be 10, it can be 100, it can be 1 million, it can be 2, 3. The moment I see that this target variable has numeric numbers this way, it is what? Which problem is this?
Regression.
A regression.
Sorry.
But the moment I see that the target variable has something like yes, no.
Just two answers or options.
2 or 3 ahead. Yes, no. It can be black. It can be blue. It can be white. Is it not? Or orange. Is it not? So here can be 1, 0. Here can be 1, 2, 3. What kind of problem is this?
Classification.
It's a classification problem. So it is the target variable that will determine whether I see what? A regression problem or what? A classification problem. Do we get that now?
So a target variable will always be given. Like
Yes, you will know
something.
the target. That was say under supervised learning, right?
So it's not really targets, it's there.
Yes. Now the thing is that it is your understanding of the problem that will determine whether you have a target variable or not. Because actually it's the problem that you are trying to solve. Isn't it? So that is your target. That's the problem I want to solve. That's what I want to predict. Can you see that? But there are some situations you do not have this target. You don't have, you may have it there, but you may not call it as a target. You just call them as features. But how can I group these features together? Then in that case, that is no longer a supervised learning, but what? Unsupervised learning. Okay. So we are going to see some examples and see how it works. Okay. But the point is that there are so many algorithms, but there's no one algorithm that will suit every problem. Okay.
So it's not one
So how do I know
true
the algorithm to use? First of all, I must be clear with the problem. How do I know the problem? The problem depends on how well I understand where that domain is. Right? So your domain knowledge is what will actually help you understand the problem better. Okay. Once I understand the problem, again, I should also know what are the relevant data I will use. Because remember, from the problem, we need to ask questions. It's those questions that we'll be able to identify what are the variables. From the question, I'll be able to identify what are the variables I need. And from my understanding of the variable, I can identify the variable, which means I should now know how can I measure the variable and how can I get data, or where to get data from. Okay? Are we clear with this no free lunch theorem?
Yes, sir.
Yes, sir.
Clear? Good. All right. No free lunch theorem. So when you hear data scientists, they're talking about no free lunch theorem. You understand what they are saying now? Okay, now another thing again we need to also understand is that, you see, for your supervised learning, right? We talked about what linear regression. Okay, linear regression. Just understand that linear regression, what is it doing? It's going to regression. You say to regress means to go backwards, is it not? It will go backward to understand the data, behavior of the data in the past. And then at the end of the day, it will help you give you what they call a line of best fit. This line of best fit is that your regression equation, is it not? So this regression equation summarizes the behavior. It summarizes what? It summarizes what? The behavior. So once I understand the behavior, the past behavior, summarizes past behavior. So once I understand this behavior, now I can go forward. I can use to predict what? Going what? Forward. Okay? So the first thing needs to go, you need to go backward to understand. Okay? And this is what we have done normally in our what? Excel. Okay? So for our target variable, where your target variable have random numbers, is it not? Random numbers. We use what? Regression there. Is it not? We use regression. It has number, it can be 1, it can be 2, it can be 100. But where a situation where your target variable is binary in nature, when you say binary, yes, no, 1, 0, 1, 0, is it not? It's binary in nature, isn't it? So for regression, this is a classification problem. Is that not? I think this is what we have said.
Yes, sir.
Good. Now, once we see that it's a regression problem, the algorithm that we use is a simple linear regression model, or what? Multiple linear regression model. Can you see that? It can be simple linear or multiple linear regression. Okay, but most time, because we have plenty features, most time we are using what? Multiple linear regression. So that's why we hear LN, linear model. Okay, or in some places they will tell you GLM, generalized linear model. Good. So we use a linear model here. But in the case where we have 1 0 1 0. Okay, so they are just two, is it not? So this is called what? A binary. So the algorithm is called binary logistic. Binary what? Logistic what? Algorithm. Binary logistic algorithm. Okay. If, for example, you have another one, it can be 1 2 3. Can you see that? 1 2 3. There's an order to it. That means 2 is higher than 1, 3 is higher than 2. This is called what? Ordinal logistic algorithm. It's called ordinal. Can you see ordinal? Because 2 is higher than 1, 3 is higher than 2, 3 is higher than 1. You know, so that's an order. So that is what ordinal. So in that case, you have what they call 2-bit regression, pro-bit regression. See, it is the problem that will determine the algorithm we are going to use. But most time, what you see them use is either regression or this binary logistic. Okay, but you still have quite a lot, and we are going to see them in practice because all of them have their assumptions. They have their what? Assumptions. Because when we are going into regression, regression in itself can only make sense when you satisfy most of the what? Assumptions. Okay, when you satisfy most of what? The assumptions. Okay, so when we hear binary logistic, when do you use binary logistic? When do you use binary logistic?
Yes or no?
Under classification situation.
Yes, other classification. Okay, so these are other types of classification algorithms. Can you see that? So you have decision tree, random forest, bootstrap, XGBoost, light GBoost, cat boost. All these are different types of what? Classification what? Problems. So whenever you are running it, you don't just run one. You can run all of them and now see which one predicts it was better. So it's based on the one that gives you the most accurate result that you now go with. Do you get that? So these are all the different forms of what? So you see, you know decision tree. I'm sure in class you have done decision tree now.
Yes, yes.
Yeah. So now that decision tree is also an algorithm that will now use to now do the prediction for you, whether it is this or this, because probabilities. Okay, it's probabilities. Is it this or this? What is probability that is going to be yes? What is probability is going to be no? Okay, so that's how we have other ones, supervised learning algorithms. Okay, so we said that there's no one best, is it not? And that's why we use as many as possible, but we don't choose which is the best. Okay, for your unsupervised, we now have what they call K-means or cluster means. They call it K-means. Or you have what they call PCA, principal component analysis. So you have so many features. So we now have to group them together. So we call them factor or factor. Have you heard of factor analysis?
No.
Okay, factor analysis. Okay, no, I think what we try to do. So let's look at this. Is this a classification or is it a regression problem? Is this a classification problem or a regression problem? Based on this data you are seeing.
Classification.
Why do you say classification?
Male and female.
The 0 1 0 1. Either yes.
What is 0 and 1? How do you know whether it's classification or regression problem? What will determine it?
It seems like male is attached to 1 and female is attached to 0.
It's more like a binary thing. So,
what determines whether it's a classification problem or regression problem based on this data?
We look at the target.
You look at the target. The moment you see the target is what? 1 0. What kind of problem is that?
Binary.
That is a binary
it's a
classification.
Isn't it? It's a classification problem.
Yes.
Yes.
Which algorithm can we use?
We can use
can we use?
Logistics.
Which logistics? Binary logistic what?
PLA.
Exactly. Somebody this is calculated at the back.
I think it's Ayobami Akin Bile.
Yeah, I think the Yaba means network. Yes.
Okay, all right. Good. Okay. So what we have said, once you look at the target variable, ask yourself, if I'm seeing 1, 2, 5, 10, 15, 20, you see, the numbers are random. Okay. Which means I am likely going to predict a number, is it not? So that's telling you that is what? What type of problem is that?
Regression.
It's a regression problem, is it not? What algorithm
Yes.
are you going to use?
SLM, single learning
Yes,
model.
linear regression, You know, so it can be simple or multiple. But once I look at the target variable, I say, okay, this is target variable, and it has 0 and 1, 0 and 1. What does that tell me?
Okay,
That's classification problem.
The classification. So once that classification problem has just 1 and 0, which is the most appropriate algorithm?
Binary logistics. Sorry.
Binary logic. That is all you need to learn from here. That's all. It is once you understand these two that you now start building every other thing. So is this clear?
Yes, sir.
Yeah.
Clear.
Now, like for example, feature 1. Assuming feature 1 is my target variable, what kind of problem is it?
Regression.
Is a regression. Why? How did you know it was regression?
Because there are various numbers.
There are various what numbers exactly. If, for example, feature 2 was our target variable, what type of problem is this?
Classification problem.
Classification.
What classification problem? Correct. But you see, because we cannot use, what they call it now. We cannot run the data the way it is, right? So what do we need to do? We need to now transform this from a what qualitative to what quantitative by assigning number. So, for example, if it's a male, what do we assign?
0.
1 or 0. So depending on the feature. So, for example, let's look at the effect of female. Let's say female on performance. Can you see that? Female effect of female on performance, right? So let's look at this. Anywhere I see female, what do I do? Anywhere I see female, what do I do? Because my interest is on female, is it not? So that is my interest. So anywhere I see female, what do I do?
Assign a number.
I will assign 1 to it. Otherwise, 0. Can you see that? So in that case, if I'm only interested in female, so here will be what? Here will be what? What will I assign here? Eh?
Oh, 0.
0. Here.
0.
0.
0. Here.
0.
Here.
0.
Here.
1.
Can you see that? So in practice, this is how the data will now look like. Before I run the regression, this is how the data will look like. Which means I will have to replace all this male with 0. Replace all female with what? 1. So what am I doing? I am what? Coding. They call it what? Encoding. They call it what? Encoding. I am coding my data. Because I cannot run the data using what text like this. So I have to convert them to numbers. Can you see that? So if I'm running it, this is how we run it. It will be 1000, 00, just like that. Is this clear now?
Yes, sir.
So all those your features now, you have to now convert them to numbers. Okay. Now, another thing again we need to do, we need to break the data into 2 parts. We have the train and we have what? The tests. We have the train and we have what? The tests. which means I'm using these two. So I'm writing the model now. It means my target is a function of what? Feature 1, is it not? And what? Feature what? 2. Is that not it? So I am using these two variables to try to predict this. Is that not it? I'm using these two variables to try to what? Predict this. Okay? Which means by the time I want to predict it, right? Because I'm going to predict what's of the future. Let me first of all break it and now see. Okay, you that already exists, let me break it into two parts. So this trade data, we have either they call the 80-20 rule, or sometimes they use 70-30 rule. So either I use 80% of the data to trade, or 70% of the data to trade. Why this 20%, which means, you see these are the outcomes, this is not, this is the actual data. Can you see that this is the actual data? This is the actual data. So what it's going to do, I will run the regression. How am I running the regression? I'll run the regression like this. I have my targets with my feature, is it not? So if I have my A plus B1 F1, do you understand this? Plus B2 F2. Do you understand what this one means now? Do you understand what this means?
Yes.
Like, regression formula.
That is the regression formula, is it not? And what is my objective there? To determine the value of what? A, B1, B2. It is when I get those values, I will put it inside here to now get the value of what is my target.
Target.
Is that not how we do it normally in regression?
Yes.
Yes.
Good. Which means that once I have done that, so I will use only the trade data. I will use only this trade data to run this regression. I will use only this trade data to run this what? Regression. So based on this regression, I'll come up with this model, is it not? I will now use this model now to now test. Are you going to predict this guy for me or not? So that is the prediction. It's not going to predict. So you can predict here as 0. You can predict here as 1. You can predict here as 1. You can predict here as 0. You can predict here as 1. Is it not? So this is the actual data. This is what? The prediction. They predicted.
Predicted.
Is it not? So what do you now do? You will now compare this actual data with this prediction value. So let's say from how many data sets did we have? We had 1, 2, 3, 4, 5. We had 5, is it not? We have 5. Out of these 5, how many did he get correctly? How many did he get correctly? He got 1, he got 2, he got 3, he missed this one, he got 4. So 4 over 5. 4 over 5, what's the percentage?
80%.
90%. 90%. Because this model, is it not? It did not see this data. Can you see that? It did not see this data. It only predicted based on what he has seen in the past. This 90%, is it good enough? Can we rely on 90%?
Can.
It's 80%.
Yeah?
It's actually 80.
Is it 80 or 90? Okay, come.
80%.
It's 80%.
Okay, 80%. 80%, is it good enough?
It is.
Is it good enough?
Won't it depend on the domain you're in?
Yes, right. But again,
90 to
generally-
95.
yeah, you said what? Hello?
I say within 90 to 95.
Now you see,
The confidence
90 to 95. Yes, you know, actually we want 100%.
The confidence level is 1% and 5%. So
We need
this
100%, but it is almost impossible to get 100%. But the closer it is to 100%, the better. Is that not? So which means if I have two models, one is 80, one is 90, which one will I go for?
More accurate 90.
which is what 90% what, is it not?
Mhm.
So that is why when we try different algorithms, they will give you what different what accuracy level.
Okay.
So which one do you go for?
The one with the highest accuracy.
Good. The one with the what highest. And that is exactly what happens in those Kaggle competitions. So it's whoever model what predicts most are what accurate. Now sometimes where the data is too small like this, it can lead to what they refer to as what overfitting. Overfitting. Overfitting means that, oh, because I've been seeing this data, I'm already familiar with this data. So even when I see a new data that is almost within the same thing, I will predict it very high. But when I bring a completely new data set, then my data now becomes what? Very small. My prediction now becomes maybe like 40%. That means this your model is what? Overfitted. But in a situation where, oh, the model is predicting maybe 40% or let's say up to 60%. But when I give you data it has never seen, it's now predicting about 95%. It is called what? Underfitting. It's called what? Underfitting. It's called under. Have we heard of that statement before? Overfitting or underfitting?
No.
No, sir.
So your model can either be overfitting or what? Underfitting. Okay. So sometimes that's why we need to what? Run them as many times as possible to now try and now see whether it is what accurate or what or not. And again, your domain knowledge will determine it. But you see, that's how you want to evaluate how well your model has performed. You now need to do some kind of other things. So when it is a regression problem, when it's a regression problem now, how do I evaluate whether this model is doing well or not? So we hear of mean absolute errors, mean square error, arrow square error. You have heard of arrow square, is it?
Yes.
That your arrow square is also what will determine the degree in which your model can what predict the power, the prediction power of your model. Okay, root mean square error. They are all telling you the same thing but in different language. So if I have two models, what I can do, I can take for example, maybe root mean square error. Root mean square error, one we have 2%, one we have 10%. Which one will I go for?
2%.
One has 2%, one has 10%. Which one will I go for?
2%.
2%. Why?
Lower.
It has the least what error. Can you see that? So that is for regression problem. For classification problem, we have to first determine the accuracy, then do what they call a confusion matrix. Hey, confusion matrix. At first, we are going to be confused because it's always confusing. You see there what confusion? It can be confusing. Okay, so we'll see what that matrix is about. Okay, so we use confusion what matrix. And all this we are going to see how we actually would apply them in what practice. So see the confusion matrix. Actual, predicted. Do you understand what this one means? Actual, predicted. Do you know what that means?
No.
Actual, predicted. Now remember this our data here that we try to predict. That's our 1 and 0. Remember here was 1, 1, 1, 1. This was all actual, isn't it? So it can either be 1, 0. Can you see that? 1, 0. Okay. Or let me put 1, 0 here so that you can see it. So let's look at it. This is actual data. This is predicted data. You know, at the end of the day, see that is 1 or 0, is it not? 1 means it predicted that it happened, or 0 is it not that it did not happen. 1 it happened, 0 it didn't happen. So if I have, for example, 1, 1, 1, 0, 1, 0. This is the actual data. But when it predicted 1, 0, 1, 0, 1, 1. So what has happened? 1 is actually happened. 0, it actually happened. Is it not? In this data. Is that not what happened? 1 is actual. It actually happened. 0 did not actually happen. Okay? Now, it's just like say this is, let's say this is female 1, female 1, female 1, male 0, female 1, male 0. Is it not? So this is the actual data. You will now give me different features to predict whether it's a male or female. Was it a female? Was it a female?
Yes.
Based on the actual data, was it a female?
Yes.
Yes.
Did you predict it as a female?
Yes.
Yes.
Was it a female?
Yes.
Did you predict as what did you predict it as?
Male.
Male.
Did you predict correctly?
No.
No.
Was this a female?
Yes.
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 Did you predict as a female?
Yes.
Yes.
Was this a female?
No.
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 Was a male, is it not?
Yeah.
Did you predict as a male?
Yes.
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 Was this a female?
Yes.
Yes.
Did you predict as a female?
Yes.
Yes.
Was this a female?
No.
No.
A male, is it not?
Yeah.
But it predicted as what?
Female.
It's female.
Can you see that now?
Yeah.
So it means either ways 1, 0, 1, 0. Is that 1 or 0? Is that male or female? Is it not? Is that what? Male or what? Female. Either what? Male or what? Female. Now you were actually sorry, this is female actually. Female, right? This one is female, right? That is actually female. 0 means male. Actually what? A male. Is that not it? Actually
Yes.
female. Actually what? Male. Okay. Why here you predicted as what? Either a female or a male, depending. Is it not? Depending, either male or female. It now depends. Okay. But all we are trying to see that you actually predicted what? Female. Can you see that? Because our interest is on what? Female. So let's look at the first one. Was it actually a female?
Yes.
Yes.
Did you predict as a female?
Yes.
So you're
Yes.
a female. It was actually a female. You predicted as what? A female. This is what they call what? True positive. It's called what?
Oh,
True positive.
positive.
Can you see that? You were actually a female. You predicted as what? A female. So this is called what? True what? Positive. Let's look at the other one. You were actually a female. You predicted as what?
Male.
A male. Was it correct?
No.
So it's called what? False negative. It's called what? False negative. Okay. Let's look at the other one. You were actually what? A male, is it not? You were actually what? A male. But you predicted as what? You predicted as what?
As female.
You're actually a male,
As
but you
a
predicted
female.
as what? A female, is it not? This is called what? False positive. It's called what? False what? Positive. Do you get that?
Yes, sir.
Let's look at the other one. You were actually a male. You were actually a male. He predicted you as a male. Is it not? This is called what?
True negative.
True what? Negative. True what?
Sorry,
Negative.
Francis.
Yes.
So maybe I mixed it up, but the confusion has already started.
Yeah, I know that is called confusion matrix.
I thought one we're going to, so it looks like we're answering different questions with only one side of the matrix.
Yes, exactly. What you're interested in.
So like
Okay.
you just pick only female and answer.
Yes, only female, because that's my target. That's my target.
Okay.
Female is my target. Female is my target.
That means the accuracy of the test is sum of all the true positives and true negatives.
Thank you. That is it. That is the actual. I don't want to give all the full names, technical names now, but this is just the basics. But actually, you are right. This is exactly what you want.
So it's not working to the answer.
Yeah.
It's not. I'm
No,
confused.
what we are doing here, I'm trying so that you understand what's happening at the back end. All these things are going to be programmed, right?
Okay.
I'm just trying to show you so you understand what's actually happening.
Okay. So
That's how they arrive at this matrix. That's how they came up with this matrix.
Okay. So I should not try to understand it more than the one I've understood.
No, just once you understand, like just keep it, hold on to it, because very soon, in fact, you'll be done like, hey, I thought I understood this thing though. If you understand it like this, just hold on to it. Don't think about it more than this.
Okay, can you do one more example?
One more example, okay.
Yes.
What do you want to predict? Let's say, what do you want to predict? What do you want to predict?
Female.
Okay, you still want to use female. I thought I want to bring another example.
Tall and short.
Tall and short. Is it not? Tall and short. Okay, tall and short. So there are certain features we can now say whether this person is tall or whether this person is short. Is it not?
Mm-hmm.
Good. Now, the moment we have now broken it into two, tall and short, what type of problem is that?
Classification.
Classification problem.
Classification word problem. Say what? Classification word problem. Okay, is a classification word problem. Which means my target variable is what? What is my target variable?
Let's pick top.
My target variable is what? Tall, Abby?
Yes, sir.
Is that not it? Tall.
Yes.
So it means anywhere I see tall, assign what?
1.
1.
1.
Otherwise, assign what?
0.
So this is height, isn't it? So my target variable is height. My target variable is the height, isn't it? My target variable is the height. Wherever is 1, 1 means what? Tall. Why 0 means what? Short.
Not
short.
Isn't it? Which means if this was my actual data I have, it means that this is supposed to have been what? Tall, tall, tall,
short.
This is short now. This is short. This is tall. This is what? Short. Is it not?
Mm-hmm.
After running the model, I now gave the model. I test this data now. Predict it for me. He predicted this guy as tall. Predicted this guy as short. Tall, short, tall, tall. So it has predicted this model. Is it not?
Mm-hmm.
So once you have predicted it, we now need to compare what I have predicted. Let me compare with the actual, whether this model actually is accurate or not. Is that not it? Which means what I'm interested in is in tall. So it can either be tall or short. You can be actually tall or actually what? Short. He predicted the person as tall, is it not? Or not tall, which is short. Okay? So this is the actual, this is what he predicted. Can you see? In all this is actual, it's either 1 or 0. In all this predicted, it's either 1 or what? 0. So now let's look at it. This person is actually tall. He predicted what? Tall. Can you see that? The person is actually tall. He predicted tall. It is referred to as what? A true positive. Can you see that? True what? Positive. Do we get that? Now look at the other one. The person was actually tall. He predicted him as short. He was actually tall, predicted him as what? Short. Isn't it?
Mm-hmm.
So that is what?
True negative.
Actual. False negative.
False what? Negative.
Negative.
False negative.
Yeah.
Now let's look at this. How do I know whether it's true or not? Actually, was tall, is it not?
Mm-hmm.
You predicted it as what?
Tall.
Is it not? Was it true?
Yes.
Is it
I
not? That's why
predicted
that was
fine.
true. You predict this one was actually true. He predicted it as what? Not
Not
it
true.
was tall. It's not predicted as what? Not tall. That makes it what? False. So that's the false negative. Let's look at the other one now. You were actually short, and you predicted it correctly as short. Can you see that?
Yes.
You were actually what? Short. He predicted you as what? Short.
That's true negative.
That's what?
False
True
positive.
negative.
True
It's not
what?
true
That's
negative.
what? True what? True negative.
Negative.
Okay.
True what? Negative. Because it's true.
Okay, yeah, it's true.
Can you see that? Because it's true. You were actually what? Short.
Mm-hmm.
I predicted you as what? Tall.
Tall.
That is what?
A false negative.
False
Positive rather.
False positive.
False positive.
False positive.
But what we're actually interested in is a what?
Tall. True.
Yeah, this
Positive.
is what they
and
call the precision. This is precision. It's called precision.
So it's a sort of contracts or something.
Yes, yes. No, later we'll see it in practice how it works. We'll see that in practice.
Okay.
But this is just to have an idea of what it looks like. Please take note. Confusion matrix is usually used for classification problem. For regression problem, you either use your arrow square, root mean square, error. Okay? Root mean square what? Error. Okay? Now, let me show you something else. And that way, again, we can also understand this. Is okay, let me use a picture. I think a picture will make more sense for us. Let me use this one. I think maybe this one will make more sense. Maybe this will make more sense. Okay, beautiful, beautiful. I've seen this one now. Beautiful. Let me try and open this. Rub all these guys off. Maybe I will share. Let me rub this off so that we can see it. Okay. Let me see another one that will give me exactly. There's a picture I want to try and get out for us. Beautiful, beautiful, beautiful. Now let me bring this. I think this one will make more sense for us. Let's look at this guy. What do you want to predict? What do you want
If
to
you are
predict?
pregnant or not.
Pregnancy.
Yeah,
or
whether
not.
you are pregnant or although this one they have switched it. This is how we did it now, is it not? This is how I explained it just now, is it not? But their own case is this way. So it's just the reverse. Okay, but just let's understand it. You are actually pregnant, is it not? And you are a woman. Is it not? You're actually pregnant and you are a woman.
Yeah.
Yes.
Okay. You are actually pregnant and you are a man. Can you see that? That is what? False.
False positive.
Yeah, false positive, because a man cannot be pregnant. It's not. You are not pregnant, but you are a woman. That means he predicted that you are what? Pregnant, but you're actually not what? Pregnant. Okay, that is called what? False negative. You are not pregnant and you are a man. Is that not correct? Is that not possible?
Yes.
So the one we actually make, which one is actually the accurate one?
You are pregnant and you're a woman. True
Yes.
positive.
and
But
true
Master, I
negative.
have a question.
Yes.
So, what if it's another woman? Because here it seems like we have to identifiable sex. Obviously, man cannot be pregnant.
Yes, man cannot be
But what
pregnant.
if it's two females?
Good. So now that you know, all this is just a summary. It will be a list of data. Women, men, pregnant, not pregnant. So there are some that the model will predict it correctly. Some it will predict it falsely. That's what we are saying. In that
Okay,
list
so
of data,
the question is,
yes.
okay, what I say that even in that pool of data, I'm assuming there'll be females that will not be pregnant.
Yes, exactly. So when he predicts them as they are pregnant, when actually they are not pregnant, it's called what? A false negative. Can you see that? A false negative. It's just like COVID now. Some people, they have symptoms of everything COVID, but they are not COVID, but they will go and write COVID. That is what? False negative. You see that? But which is more dangerous? Which is more dangerous? False negative or false positive? Which is more dangerous?
False negative.
That's it.
Which is more dangerous?
I think false negative, because you look like the issue and you're not actually treating the issue.
It looks like the issue, but it's not actually the issue, isn't it?
Yes.
Okay. So sometimes we have to also look at it, but actually it is this one that will determine how we know whether it is what? True positive, true negative. Do you get? So what we have what they call, when we do it in practice, I will now explain what they call precision recall. Precision recall. Okay? Precision and recall. So when we get to the practice, I will explain all those ones. But now just to show you what they call it now. Just to help you understand what this confusion matrix is about. So are we clear with this now? Are we clear with this confusion matrix now? So this is just a way to evaluate whether that our model is accurate or not. Okay, good. Now you see, after you have done the model, the next aspect is to now deploy. But again, this is where pure data scientists, pure data scientists will talk now, to now deploy. Okay, you collect the data, do all your cleaning, your transformation, do everything, isn't it? Now you model training. So when you say model training, do you understand model training now? Do you understand model training?
Train and test.
Yes.
Exactly, all those train and test, exactly. That's what they are doing. Okay. So you do those pre-processing. You know what they call pre-processing? You saw where we have male, female, we're converting the 1, 0, and the rest. All you are doing, you are what?
Yeah.
Okay.
Okay.
Then you now model the data. That's your regression model. Okay. When you now run it, you now have what they call validation and explainability. That means it must practically make sense. Okay. Now, once that is done, you have done the accuracy, it makes sense. The next thing is to deploy a solution. Either you now build like you have to deploy it live, either on the web or on an app. Okay. You can do it either on your machine or on the server. Okay. So that's your user interface. You can either be on the web or on an app. Okay. Then you have an API. Have you heard of an API?
Yes, sir.
Have you heard of an API? What is an API?
Yes, sir.
Yes.
Application interface.
Yes, application what?
Programming
Interface.
interface.
So sometimes you can now connect it with another program, just like you want to do registration. You say sign up with Facebook. You should not use your Facebook account or Google account to sign up for something. What is it doing? It's going to connect to another application to connect to you. So that is the same way that it works. Okay. Once you can build out your API, then you now go to your deployment. So there are different frameworks. So all those things, they are now called the solution architecture, or what you call wireframes. Okay. So this is your local machine. The users now can have a browser to now connect. That's what they're now deploying or consuming your model. Okay. So again, just imagine your Netflix. your Jubian. Is that not what happens? Is that not what you do? You now go to the browser, is it not? When you buy, now make prediction for you now what buy or not buy. Okay. So just like this, just a typical prediction. So after all those your features you have got, all those your features that you have got, you now deploy it. They can now put the data. They will enter the data, enter the data, enter the data, enter the data. Then you now what predict the selling price. Can you see that? Have you seen what has happened? All these are called what? All these year, price, kilometer. What are they called? Fuel type, petrol. What are they called?
Features.
They are called
They
your
are
features.
features.
Exactly. Selling price is what?
Your why?
Your
Your target.
Target.
Your target.
Your target.
Which problem is this?
Looks like regression.
This is a
Regression.
regression problem. That's it. Because you are predicting the. So this is how you now deploy it live. Can you see that? This is now the end product of everything we are used to what deploy. Okay. You now what deploy it. Okay. Then you have another, this is what they call Postman. It's just an app, right? But again, it's just to test your APIs, whether they are working. Because you need to also connect it to now check whether if I connect to another website now, will it work? So you can also put all those features and now do your word prediction. Now tell you can sell your car for whatever. So all you are doing, your other word deploying it. So it's not enough for you to just leave it in Excel. You see that's why you cannot just use Excel for this type of things. Okay. But this is just an end-to-end package of everything to do. Okay, in terms of your machine learning. So there are certain packages we have looked at. We have looked at NumPy, is it not? We have looked at Pandas, isn't it? We have looked at Seaborn. We have looked at Matplotlib. Okay. Now what we are going into, the new libraries we are going into, we are going to what they call scikit-learn. Scikit-learn. There are quite a lot. There are quite a lot. I'll show you some of them because we talked about most of them when we are looking at what they call it now. When we talked about the different applications, we see some of them. Let me see where they talk about them. Okay, I'm sure it's still at the beginning. I'm sure it's still at the beginning when we talked about the different framework and tools. Can I say the one now? Okay, so I will say the one. So the one here. No. Okay, we'll look at other. I'll show you some of them. Okay. I'll show you some. But the one we are going into today, we'll go into scikit-learn. But let us quickly go to Excel. Let us quickly run the regression in Excel. Okay. So understand what is happening. Which data do we have? Which data do we have? Do you have any regression? Superstore data. Now that superstore data, let me see. Is there anything we can predict there with superstore? Is there anything that was okay? Let's use a simple example there. There's one file I usually give us for regression. That one that has advertisement and sales. Do we have that file, advertisement and sales? Because that one will make more sense for us. Advertisement and sales. Regression. Okay, regression. It's called regression data sets. Do we have it? Regression data sets.
No, we used to have the data sets long. Okay, I think that's from class.
Yes, in class. Yes, in class.
Yeah.
Okay, let me see if you don't have it, let me see if I can share regression data sets.
Okay.
If I close that file, okay, regression data sets. Okay. Okay, I've sent it now. Check on your. All right. Do you have that now?
Yes, we have, sir.
Okay, you have it now. Okay. So let's look at something like, okay, let's look at this one now, right? Let's look at this ROI. So you see, by looking at this data, right? What kind of problem is this?
Regression.
The regression problem.
The regression problem. Okay. So how do I know my target variable? Which is my target variable?
ROI.
ROI. Okay. So ROI. What are my features?
Interest rate, bond price, and exchange rate.
Beautiful. Is it not? So it means that when I am running it, I will not have to pick. But I may not use all the data. How many points do I have here? What is the data points here? This is about how many? 32. This is 32, is it not? 32. 80% of 32 is what?
27.
It's 27, is it not? 27, right? What is left?
5.
5. So this 5 represents my what? 20%. It means that this 27 is going to be my what? Train data, is it not? Why this is going to be my what? Test data. Can you see that? So when you are running on this 27, but
It's
what
26 now.
26, okay, 26. Right?
25.6.
Then this will be 6, okay. Okay. So when you are running this 26 with the train data, then you now test using what? Test what data. Can you see that? So if it's not predicting it accurately, so what can we do? We can either introduce more variables or drop certain variables. So we'll just keep trying. That's the feature engineering, or keep creating variables until we get the one that best explains it. And that's why we talk about explainability, right? Because I can bring one variable that have an impact, but I cannot explain it in practice how it has a relationship with ROI. Okay, that's why I say these variables must be what? Explainable in relation to what? Your target variable. And when you are picking this 26, you are not just picking 1, 2, 3. No, you pick it what? Randomly. You pick it what? Randomly. Okay, you pick it what? Randomly. Then break it into test and what? Train. Then after you do that, you now what do you now do? You now run what? The data, isn't it? I'll now run what? The data. So let's say I want to run the regression. How do I run regression in Excel? How do I run regression in Excel?
Go to data.
So I'll go to where? Data.
Data.
Yes.
Your solver.
Go to data analysis, a bit solver, I think.
Data analysis.
Yeah.
Yeah. Okay. Data analysis. In fact, people have graduated now to data science.
Regression.
Okay. What's my Y?
ROI.
Now, am I picking everything?
You're picking to 26.
I'm picking to what?
26.
For this,
so let me just
27.
Okay, so that we can see what we are doing. Let me just label it. 1, 2, 2. So I'm picking to 27. This is not up to this point.
Yes.
Okay. I'm picking. Sorry. Go to my data analysis. Okay, regression. Okay. So I'll pick my Y. What is my Y?
ROI. 27.
27.
Number 27.
27 here, right?
Yeah.
Why my input rate will be from what?
DEF to 27. So, yeah. Then labels. Yeah.
So let me say output. Let it be on this place.
Yeah.
Let me put it here. Okay. So let me run the regression. So I have run this regression now, isn't it?
Yeah.
I've run this regression. Okay. Good. Now you see, when you want to now do prediction, what is it doing? So if I want to do prediction now, what is it doing? You see ROI. So if I want to do prediction, right? Now, if, for example, if I want to predict this, which means that this is equals to what? This, is it not? Plus what? This times what? Interest rate times what? This value, is it not? Plus this times what? Bond price plus this times what?
Exchange rates.
Exchange rate. So in that case, this is going to be constant. This is going to be constant. This is going to be constant. This is going to be constant, and this is going to be what? Constant. So I have what? 7 point what? So is it not? So what you are doing here is prediction. Can you see that? So if I now take it now, let's look at it now. All I'm doing now is what? Prediction. Can you see that? So where have I predicted from now? From where?
28.
20 what? So let me make it 2 decimal places. Is it not 2 decimal places? So from here to here, this is what I predicted. So this is my what? This is my predicted value. This is my what? Actual. Is it not?
Actual values, yeah.
Actual values. I can now compare. Okay. You see, there's no way you can be what? 100% what? Accurate. But take note, the larger the data, the better. Okay? And take note, as more data comes in, it's expected to what? Run everything again and keep updating and updating and updating that. Because as more data is coming in, it's what? Learning from the data and what? Getting what? More what? Accurate. Can we see that?
Yeah.
So if we look at the arrow square, what is the arrow square?
The arrow square is
0.9.
So 0.91, is that high or low?
That's high.
is high.
That's what? That's high, is it not? That is
Yes.
what? High.
High.
Okay? And that thing again, we also need to take note of. Sometimes, let's look at it the other way. You know, we ran with all these models, isn't it? We can also check, okay, what if I want to do the prediction only with significant variables, only with what? The significant what? Variables. So which means that if only these two are significant, that means I will have to drop maybe like interest rate and use only bond price and exchange rate. I can now run it again and now check. Will it give me a better result? Can you see that? If it gives me a better result, if maybe that one will give me 98% and this one will give me 91%, which one will I go for?
The one that gives you higher arrows.
The one that gives you the higher one. Okay. So this is what we are going to be doing in Python. This is what we are going to be doing what in Python. Okay. So if I see this, if I take this one, although this one is the data is quite short, right? The data is quite short, so you may not make so much meaning. So let me take this one down. So if I should now do like a okay, not so much. Although the data is quite short, but when you see over a long period of time, it be as close as possible. Okay, but the wider it is, the less accurate it's going to be. But although because this data is quite short, that's why we see when we are working with data, the larger the data, the better. So let's go back to our Python now. Let's go back to our Python. Which data set do we have now? Which data set do we have? Last time, which data did we use? Do we have I showed you how to extract some of the data, right? Which of the data do we use? Okay, you know what we can do? You know what we can do? Let's use this data, this regression data, let's use it. And let's run it Let's run it here. Let's run it to just see how it works. Do you get? So how do you run regression in Python? I think that's what we should do now. Let's run regression in Python and see how it works. So let me open my, where is my Jupyter notebook? Jupyter notebook. All right, so let me open it. So can you see my Jupyter notebook now?
Yes.
Yes, sir.
Yes.
Good. All right, so what's the first thing we need to do?
Import pandas.
Import what?
Psychic. Pandas.
Import what?
Um,
All your
I-
libraries now, pandas as PD, is it not?
PD,
Import
NumPy,
NumPy as NP, is it not? Import what? Matplot, lib, is it not? .pyplot as PLT, is it not?
PLT.
Import what?
Cbond.
Cbond, is it not?
Yes.
Cbond as what? SNS,
SNS.
is it not? So this is what we normally do, is it not? So let's run that. Okay. Now, but if I want to now go and start bringing the algorithms, I want to now use the algorithm. So which algorithm are we going to use now? Which algorithm are we going to use?
Is it for the data set, the
Binary.
regression data set?
Binary linear model. That's an algorithm.
Now, the one we ran just now, that ROI, right? Which one are we going to use now?
Simple linear regression.
Linear regression, is it not? Linear
Yes.
what? Regression, isn't it?
Regression.
So normally we have some other libraries, okay? So the library is usually called sklearn. So if I say import sklearn, can you see there? sklearn, okay? But rather than doing it this way, I already showed you how to do it another way. Say from, so I can do it either this way, or I can say from sklearn, is it not? Dot, there's a module they called model selection, okay? From sklearn or model selection. Okay, so pick it from here. What do I want to do? Import, train, test, split. Do you know what this one is doing now? Do you understand what this is saying? The model I'm using, the library I'm using is called sklearn. Inside sklearn, I have a module here called model selection. From that module is what I want to bring what? Train, test, split. Do you understand what this train, test, split will do? Train, test, split. Do you know what it does? Train, test,
To
split. What is
split
it?
the
It's
data.
the
Split the
model
data
training.
into two.
Thank you. That's our 80-20. You know, that's our 80-20. That's what it's looking
Yes.
for. Try and run it and see whether it will work. If it works, it will just be as if nothing happened. But if it doesn't work, it will give you an error. So that means you have to go and install your sklearn. Clear? Okay. Now, because it's just regression we want to do, we can also bring another library. Say from sklearn.linear model. Linear model here. What do you want to do? We want to import what? Linear regression. Can you see that? Import what? Linear what? Regression. So we have just the same way we go to data analysis. Do you see data analysis was inside somewhere? We now have to bring it out. So when you run your, did it work? We did this work because otherwise you have to go and install it.
Yes, it ran. Okay,
It
no.
ran, okay, so thank God it ran. Okay. So now let's import the data. What's the name of that data set? regression data set, isn't it? Regression data. So if I want to import the data set, how do I import the data set? How do I import the data set now? I want to import this data set. How do I import the data set?
You copy the parts.
Yeah.
Okay.
And read.
Yeah. So how do I do it now?
If for those of us that like when I tried that from sklearn.model_selection, my own did not run. What do I have to do?
How did it not run? Did it give you any error?
Yes, from sklearn.model_selection, import train test.
We'll share your screen. Let me see what's happening. Share your screen.
Okay, I think I mistyped something, so I just ran it again.
Okay. Anytime this error comes, you see like regression, now you have made mistake there. That linear regression, you have made mistake there.
This one.
Yes, you have made mistake. Look at how I spelled it. You see how the regression L, capital letter L, capital letter R. Exactly, capital letter L. Yes. Oh, yeah, wrong. Let us see. So what did he say? Name linear regression. This is not so name. So let's check the name again. From sklearn.model selection. Model. So do you see that? That's your model, right? It's going to be linear_model. Use linear_model. sklearn.no. sklearn. Linear.
Yes.
_model selection. Is it not? Import linear regression. You are running now. No, wait, hold on. Remove that your linear model. That's linear model. Remove that selection. Remove selection.
Okay.
Remove selection. Oh, yeah, run. Let us see. Thank God. So these are not the errors you are going to be seeing. All right, you can stop sharing. So let's go back.
Thank you, sir.
I'm sure up to this point, this thing will make sense now. Right? Up to this point, it should make sense. How to import the data. How to import a library. Okay. Now, if I want to get the data, so let's get data is equals to what? pd.read what? Which file
And
is
that's
it?
all Excel.
Excel. Is it not? Then what do? I will copy the paths.
Yes. And you put R.
Now, but you see, there's a sheet. You know, there are different sheets there. So sheet name. What's the sheet name?
ROI.
The sheet name is what? ROI, is it not? Because if I miss the sheet name, that's the end. So let me go to data now. So this is the data now.
Okay.
Have you seen it? Are we clear with that?
Yes, sir.
Good. So what's the next thing we need to do now? Based on what we did in Excel. What do we need to do now?
Need to run the regression.
We need to run the.
Before we run the regression, we did something.
Okay, we split.
We split the data into train and test.
We need to do the train test or split. Is it not? That's what we need to do first. Is it not? Good. So how do we do that now? That's from that our sklearn. We need to bring that library. You know, we have imported that library, so we don't need to call it here. So it means that we have our X train, X test. You know, Y train, Y. Do you understand what this is? You don't understand what this means now.
Dividing the
X test, Y train, Y test. What does it mean?
dividing the target and future and
Yes,
splitting it
yes.
between test and train.
Test and train. Good, good, good. Which means we need to know what's our train, what's our test. So which is our Y, which is our X? What is our Y?
Our
What is
Y. Y is ROI.
Y is what? ROI. So how do I extract ROI out? I want to bring only ROI. I want to bring only ROI and call it Y. So how do I do that? I want to bring only ROI. So how do I bring only ROI? Only ROI. Only ROI. How do I extract only ROI out?
Column dots.
Hey, they have come again. The column dot org.
Data dot ROI.
Yeah.
Data dot ROI.
Data.ROI. We want to extract only ROI out, right? So Y is equals to data, is not ROI. Is that it? What is the spelling? Okay, it's in columns. Okay, so let me take one out. Data ROI. Will it work like this?
It should.
It should work, Abby. What is my column? What is it? What is happening? What is it saying?
Error is ROI.
So why is that happening? So if I come here, let me check my columns, right? Data.columns. So I have ROI. What is the problem there? What is the problem?
That's a space.
There's a
After
space.
ROI.
Can you see that problem I always preach about in class? Is it not? That space can cause problem. Can you see that work now? So what can I do? Either I go back to my original data, is it not, and correct it. Isn't it? I'll correct it. Okay, that's fine. So that's the space there. Okay, so that's my Y. So anytime I call Y, this is what I will have. Is that not it? Y. Okay. Good. What about my X? How do I bring my X out? What is my X?
It's X equals to data.
Data bracket. Data bracket. Interest exchange rate. Comma.
Okay, either I use data, is it not? I'll just copy this as it is it not? Or alternatively, what can I do? If I don't do it like this, what's the other way of doing it? What is the problem here? What is the problem here? You know, there are multiple columns. You know, so I should use what? Double what? Brackets. So let's run our X. Can you see your X now? Good. What's the other way of doing it? You know, we can use a drop. We can drop what? We can drop what? ROI there. Or we can select it like this. Good. So we now have our y, we have our x's. Now we can now do our what? Train test splits. We can now do our what? Train test splits. So it will make more sense now. So this is our train, this is our x, this is our. So remember that in Python, you know, if I want to assign, how do I assign in Python? If I want to assign, how do I assign in Python?
Like is equal to something is equal
Let's
to,
say A is equals to 10, is it not?
yes,
And B is equals to what? 20, is it not?
yes,
Do you know that I can also assign like this? C comma D is equals to 15 and 30. Do you know I can assign like this?
yes,
So if I call C 15, is it not? If I call D 30, is that not it? So what are we doing here now? So what do we want to do? Train test it now. So what do we want to do there now? Yes, so what are we doing there? We want to now what? Assign the values to what? X train, X test, Y train, Y test. Please take note of how I wrote X test and Y train and Y test. Do you notice the difference? So let's do that. So train test splits. X comma Y. You know your X, you know your Y, is it not? Then what is the test size? What's the test size? What is the test size? Test size will be what? You know the rule, is that 80-20 or 70-30? Which one should we use?
80-20.
80-20.
80-20. So test size will be what?
27.
Test size will be what? 20%. That is O2.
Oh,
You get that? Then I can also use random. I can pick it randomly. So that's what they call random states. Random state. I can pick what? If I put 100, it means based on this pattern, if we put 100 or we put 101, it doesn't mean it's picking 100 data sets. It means based on this pattern of 100, it's going to pick a particular pattern. So we'll have the same data. But if you leave it, then we can pick, if you can put any number there, pick it randomly for you. But if we have to get the same data, we have to put the same random states. Okay, so let's run that and check. So if I run X train, can you see the data now? Run your own and check. Do you have a data like this? Can you see that picked it randomly? Can you see that? That is Y train. If I have Y train, can you see that? We have this one, the associated train data sets. Okay, so that's what has done. We have picked them and assigned them to X train, X test, Y train, Y what tests. You see, if it was in Python now and it was in Excel, we have to be creating them manually, isn't it? But here everything is what? Automated. So if I want to run the regression, how do I now run the regression? Okay, I have to now create the instance. So let's say linear model is equals to linear regression. You know this linear regression was in the was from here. Can you see linear regression now? Can you see that I'm calling it up now? Inside this model called what? LN. Yeah, linear model. Do you want, which name do you want to call it? LR. LR will be okay. Or which one do you prefer? LN, LR, linear model. So what we are doing here, we are creating what? An instance. So instead of me calling this linear regression, what will I call it?
LM.
LM, exactly. Okay, so if I want to fit the data now, what do I do? So how you are running this means you are fitting the data. So I'll say LM dot what? Fit. What am I fitting? The X train. What am I fitting? Y train. Can you see that? L train and what? Y. So let's run that. It's as if nothing has happened now, isn't it? Like nothing has happened. But actually, it has run a result for us. What are we looking for from this model? What are we looking for from this model? What are the things you are looking for?
The effect of the X's on the
You are looking
Y.
for, no, when you run regression, there are certain values you are looking out for. What are those values?
The p-value and the R square.
Square.
This is the arrow square you are looking for. To come up with that your model now. What are you looking for?
Oh, okay,
We're looking
okay.
for
The X,
we're
Y,
looking for
and
Y, the intercept,
A, B.
and
Exactly, intercept and what slope
interest.
coefficient. Is it not?
slope and coefficient gradient.
Exactly. So
Yeah.
if I want to run it now, so to check it out, so linear model dot coefficients, or let's do intercept first. Intercept. So this intercept, right? So this value for my intercept. Why the other one is what? LM dot what? Dot what? Coefficients. So these are now my what? Coefficients.
The 3 coefficients for each feature.
Yes, exactly. So can you see how it's done now? Because this one used random data. The one we had run, what did we get? We had, let me see if it will copy. So we had intercept as what? 24. This one was interest rate of what? 0.14. This one bond price of 0.2. And this one exchange rate of 0.37. Okay. Now, but take note, this one had used randomly, isn't it? But that one we had picked first 1 to what? 27. Isn't it? So it may come up with different distance. So that's why we say we can use different distance. But if we run it with the way we had done it before, let's say we run it without using this random state. Let's see. If we run without this random state. Okay, without the random state. So what do we do next? So we call this instance LM, or should we call it LR? Let me call it LR as the second one now. LR, okay. So let me fit it now. How do I fit it? LR dot what? Fit. Fit what? Fit what now? The X train, is it not?
X
and what? Y
train.
train. Okay. So once I've run that, to tell me it has come. So I'll say LR dot what? Intercepts. Intercepts. Okay. And the other one is what? LR dot what?
Coefficient.
You see, if you run the zone now, to give you another set of distance, okay? Because there's another package I'm going to show you guys, there's start model. So the way we run it in Excel, that is the same way it's going to come out. So it is based on this one, we'll now try to use to do the prediction. So when we come next week, I will try and show you how to do it. But this is how to run your regression normally. Okay, this is how to run the regression normally. So because of this, our random states here, and we split it into 20, 30. You can use 30, you can change it to 30 and run it. If I run this, I'm going to get a different result. Can you see that? I'll get a different result. So you can keep trying them to now check which one will now give you what's the best. Okay? So this is how to run the regression. So when we come next, we now continue from here. All right, guys, I have another session to join now. Okay?
All right.
Okay, thank you,
right.
Dr.
Thank you very
Francis.
much.
Yeah.
Thank you so
Dr.
much,
Francis.
sir.
Make sure we
Let's
practice this
win.
thing, because this now we are going into space too.
No, wala, sir.
Uh,
Thank you, sir.
all right, take care.
Thank you. There's a stop.